Hello guys, my name is Ritam and today my DBMS topic is the well ordering principle using discrete mathematics. Let's begin. Introduction to the well ordering principle. The well ordering principle states that every non-empty set of positive integers have at least element. This principle is a fundamental in discrete mathematics and serves as the basis for mathematical induction. Understanding this principle aids in various proofs and problem solving scenarios. Well-ordering principle: every non-empty set of non-negative integer has at least element. This is equivalent to mathematical induction. If Mi is true, then we can WOP is true. If WOP is true, then we can prove Mi is also true. Definition of well-ordering. Well-ordering applies specifically to sets that are well-ordered, meaning every subset has at least element. The set of natural numbers positive integer is classic example of well-ordered set. In contrast, the set of real number is not well-ordered, as some subset do not contain at least number. Well-ordered set example Z is less than equal to is a total order pose set. Every element is comparable to every other element. This has no at least number, thus it is not a well-ordered set. Importance in discrete mathematics. The well-ordering principle is crucial for providing statement about integers and combination structure. This foundation concept of mathematical induction, which is widely used in proof. The principle helps in mathematicians establish the existence of solution in various problems. Every non-empty set of non-negative integer has at least element. This is equivalent to mathematical induction. If Mi is true, then we can prove WOP is true. If WOP is true, then we can prove Mi is true. Connection to mathematical induction. The well-ordering principle supports the structure of mathematical induction or structure. Induction proves that if a property holds for a number of it holds for next number relying on the least element. This principle ensures that if a set of integers is defined where a property fails, it must have least integer where it fails. Like Pn is equal to 1 by 3, 1 by 6, 1 by 12, so on, where 1 we are substituting n by 1 when p of 1 is true, given in the example. Similarly, we can prove this for all the other elements. Example of well ordering. Consider the set of positive 1, 2, 3, and so on, the at least element 1. For the set 5, 10, 15, the least element is 5. Each non-empty subset of positive integer will always have the smallest number, demonstrating well ordering. Theorem: every non-empty set of Z plus have a smallest element, given in this example. Proof of well ordering principle. Common proof uses contradiction, assuming a non-empty subset of positive integer has no least element. By choosing any element from this subset and considering the smaller integer, we find a contradiction. This proof can be formalized using principle from set theory and logic. Well-ordering principle: every non-empty set of non-negative integer at least numbers element. Relational or mathematical concept: a well-ordering concept on mathematics, intersection of zone, lemma, and axiom, choice of set theory. Understanding this relationship allows deeper insight in ordering the hierarchy in mathematics. Well-ordering principle: every non-empty set of non-negative integer at least element. This is equivalent to mathematical induction. Induction of Mi and WOP is true and the opposite Mi is true. Limitation of well-ordering. Well-ordering is not applicable to all sets. For example, real number lack this property. This principle is typically confined to domain discrete mathematics and number theory. Misapplication of well-ordering can lead to incorrect conclusion. The well theory property: let B is the set of integer and integer n is called the least element of B. If M is an element of B, then every element of X is B is M is smaller or equal to A. Example 3 is the least element set of 4, 3, 5, 11. Let A be the set of all positive odd integers when 1 is the least element of A. These are some examples of well-ordering property. Counter examples. An example of set is not well ordered is a set of even integer which lacks a minimum element. These these elements are another counter, for example, as they can infinitely dense with no least element in certain subset. Understanding this counter example is essential for correctly applying well-ordering principle. Well-ordered set here is the some example of well-ordered set, poset, and the least element is given. Conclusion. The well-ordering principle is a fundamental concept in discrete mathematics. Its implication to various mathematical fields and problems. Mastery of this example enhances one's ability to engage in mathematical proven theory. Thank you.